Good morning and welcome viewers from Beacon Group of Companies. This is a new endeavor which we are starting and that is a podcast series. So I warmly welcome all of you to this first podcast series of Beacon Group. Hematology automation transforms the complete blood count from the tedious and time-consuming manual microscopy into the rapid high-throughput analysis. This evolution was beginning in the mid of 20th century, shifting from the manual counting to the foundational Coulter principle and advancing in today's most sophisticated flow cytometry systems. With these advances, hematology analyzer has become an inevitable part in clinical laboratory setup. Just like any other laboratory test, hematology also requires a strict quality control before the results are declared for the patient. Since today's time, 70% of the medical decisions are based on the laboratory testing. Today, we will try to understand important aspects of quality control for hematology analyzer. I welcome our guest speaker, Dr. Manoj Kahar, an eminent pathologist from the field of laboratory medicines, a practicing pathologist, and an NABH assessor for the blood bank with the expertise on the subjects like transfusion medicine, histopathology, quality assurance for clinical laboratories. Welcome, Dr. Kahar.
Sir, I am very thankful for you and I thank Beacon Group of Companies also for providing me this opportunity. And through this podcast, we want to discuss important issues of laboratory practice. And as you rightly said, we have chosen the topic of quality assurance, quality control of hematology analyzer today for this first podcast series.
That's really great. And I'm sure this will be a very useful topic for all the practicing pathologists, all the people who are running the medical laboratories. We talk about the hematology analyzer. That means it's an automation system for which we are talking about. We understand that when we talk about the automation, there are many aspects of automation which provides handful of the advantages to the clinician or to the person who is operating that. We also understand that when we talk about the automation, accuracy, precision and all these things are automatically being generated by the instrument itself. Still, why there is a need for a quality assurance of hematology analyzer?
Sir, as you rightly said, 70% of the medical decisions, they are based on laboratory reports. In any clinical laboratory, hematology analyzer is a very vital instrument. A CBC report holds a lot of importance and provides valuable inputs for the clinician who is managing the patient. And I would go to the extent that ECG bearing the importance for a cardiologist, a CBC report holds the same importance for a physician or a general practitioner because it provides all the basic information. And if that report is not a correct report, then it can lead to misdiagnosis, incorrect treatment decisions like inappropriate transfusions, or maybe some inappropriate medical treatment decisions which can harm the patient. So, a CBC report should be accurate report, it should be a true report.
Correct. Sir, what qualifications will be needed by the laboratories for hematology analyzer before the results are reported to the patient?
So whenever you buy a new hematology analyzer, the hematology analyzer comes to your lab. So the person who is operating this instrument or the person who is going to authenticate the reports, they have to make sure that the instrument has proper installation qualifications,
Okay.
then operational qualifications, their performance qualifications, which we routinely termed as IQ, OQN.
Okay, so that is, according to you, that is the most primary pre-qualification which is required for an hematology analyzer. Is this required by any regulations of the laboratory work? Is there any regulation kind of the things which?
So we have a ISO 15189 standard,
Okay.
which is an international standard for medical laboratory personnels.
Right, sir.
And that standard specifies in some of its clauses where you need to have this IQ, OQ, and PQ. And this is a requirement by ISO 15189.
Okay.
And NABL also uses this ISO 15189 as a mother standard, and they have their own standards, and all are listed in NABL 112A and 112B. And these are freely downloadable documents and you can refer to them, and then accordingly you have to have your IQ, OQ and PQ.
Okay, that's a very useful information, I suppose. And as you very rightly said, along with the justification of the quality, these are also the documents which are required by the regulatories also.
Yes.
And having those documents, I think it is going to give mostly a comprehensive status to the laboratory that they also undergoes the regulatory requirements for running a good clinical laboratory.
Definitely, sir.
Right, sir. There are terms which are very frequently used in the quality control. We are very familiar with those terms and we are very frequently using them. The terms are like validation and verification. Sir, can you please elaborate these two words, how they are different from each other and what they actually mean?
So there are various definitions given in ISO standards, and as I've already let you know that the mother document for clinical laboratories is ISO 15189. And when you refer this ISO 15189 standard, it has first all definitions. And when you go to the definition of validation, the definition states that it is confirmation of plausibility for a specific method or application through the provision of objective evidence that specified requirements have been fulfilled. Nice. Now, this validation is a very demanding task. Usually, this validation is done by the manufacturer. It is a very resource rigorous thing, and there are lots of experiments to be done. They are to be done on a large number of samples, variety of samples, and then manufacturer, based on all this data, will have manufacturer's claims for his particular analyzer. And this is a very rigorous exercise. You need a variety of samples, and then based on these experiments, manufacturer will have his manufacturer's claims. And these validation studies are also to be provided, subjected to regulatory authorities for approving that instrument.
Oh, I see.
Now, the second terminology is verification. And verification is to be done by the end user, means the laboratory.
जब वो लैब में मशीन आता है उस वक्त उनको करने का काम
Means the
वेरिफिकेशन.
laboratory has to do this verification. And verification is actually confirmation of truthfulness of the manufacturer's claims. So whatever the manufacturer is claiming, the end user will verify at his end that the manufacturer's claims are true. And I will give you a very simple example. Just understand this example.
Yes, sir.
If a car manufacturer is coming with a model of a car, so what he will do, he will take 1,000 new cars, he will have 1,000 drivers, and he will fill 1 liter of fuel in each of these 1,000 cars. And he will instruct the driver that you drive this car until your fuel is finished. Exhaust. And then he will take all the data from all these 1,000 cars. Now, the study will also be in two situations. One will be on a state highway, other will be in a traffic.
Okay.
Right?
Right.
And then all those data will be subject to statistical calculations. And then manufacturer will claim that my car will give average of this many kilometer per liter of fuel on highway and in traffic. These are manufacturers' claims.
Okay.
Then they count with validation. And now you know you need to have 1,000 cars. I'm giving an example. 1,000 cars, 1,000 driver, 1,000 liter petrol. Now, as a purchaser, what I will do, I will purchase one car.
Correct.
I will fill 1 liter petrol in it. Then I will drive through and see whether the claims of manufacturer are true or not.
Matching is.
Am I achieving that average?
Right.
So that is verification.
Oh, absolutely. बहुत बहुत अच्छे से आपने इन दोनों शब्दों का जो explanation दिया. I think it will be one of the very useful kind of an example that you have given it for the automobile vehicle. तो validation की जो हम बात कर रहे हैं, what we are talking about validation, right? तो इसमें बहुत सारी चीजें जो है वो मैन्युफैक्चरर को ही करनी है. तो which are the performance characteristics which has to be evaluated by the manufacturer before putting the instrument into the market?
So there is a very good document what I will suggest to refer by the laboratory personnel as well as the manufacturer. And this is a CLSI guideline.
Okay.
It is H26A2. And if I'm not wrong, the last edition was in 2010. So I am requesting all of you to refer to this document, which is CLSI H26A2. And this document talks of validation, verification, and quality assurance of automated hematology analysis. And this document lists lot many things what the manufacturer has to do.
Okay.
And here the manufacturer has to do limit of blank,
Right.
limit of detection,
Okay.
limit of quantification, linearity, carryover, imprecision, then your analytical measurement interval, AMI, then which data you will include in your validation study, which data you will exclude. So lot of experiments have to be performed by the manufacturer to make claims from the manufacturer side for the performance of the hematology analyzer.
Correct.
And this is a very good document which is a guiding document for both validation and verification. And the third thing, also for quality assurance of hematology analysis.
Sir, we talk about the requirements, as you very rightly pointed out from the CLSI, the requirements by the manufacturer to fulfill before sending the instrument out for the end user benefit. Of course, because in this podcast of mine, a lot of my valued customers will also be interested to see this for benefit of the end user of the hematology analyzer. Can we know little bit in more detail about these particular specifications? Like for example, you said about limit of blank, carryover, the analytical measuring interval, lower detection limit, and quantification. Can we know in brief about each of these characteristics?
So first, let us start with limit of blank.
Yes.
What is the limit of blank? Limit of blank is highest measurement result that is likely observed for a blank sample, right?
Okay.
And a user every morning we have to have a blank run, and the manufacturer will let you know what should be the blank, and the user has to refer to the operator manual where in the performance specifications the manufacturer will let you know what are the blanks, and then you have to see. So what I'm telling, what is limit of blank? The highest measurement or result, highest measurement result that is likely observed for a blank sample.
Okay.
Right. One more thing I'll let you know. After running a blank sample, never ever run a patient sample which is to be reported for that day.
Okay. Okay.
In between
Why?
that, in between that, you have to run either a control sample
Right.
or control material or a yesterday's known patient sample,
Right.
and that is termed as priming.
Okay.
So that is most of the laboratory personnel, they follow this thing. So my recommendation is after doing the blank, please do not analyze your that day's patient sample. In between the two, run either a control material or a known patient sample from yesterday, and then start using the instrument.
So how do we do this priming and all the for other
Only-
instruments? Similarly, you recommend that there has to be a priming after running the blank in the morning. There has to be a priming.
So ideally,
And-
most of the laboratories they do run a control sample
Correct.
or a
Correct.
known
Correct.
patient sample from
Correct.
yesterday's.
Correct. Correct. That's wonderful. What do we understand or what do we mean to say by carryover? ये क्या?
First finish this comes limit of blank, limit of detection, and
Okay.
limit of quantification.
Yeah, we
So
will talk.
these are interrelated.
Right.
Right?
Right. Right.
So limit of detection means it is the particular value which can be detected with stated probability.
Okay.
So this is the lowest amount of a measurand which can be detected with a stated probability. This is your limit of detection. And many textbooks, they also write LLOD, that is lower limit of detection. And some books write LOD.
Can be something something like sensitivity part we talking about?
We are talking of that part.
Okay.
Right?
That's great.
And then there is the other term, which is termed as limit of quantification.
Okay.
And limit of quantification is lowest amount of measurand in a sample that can be quantifiably determined with stated acceptable precision and trueness.
Right.
So there are difference.
Okay.
The lowest thing which you can measure with a stated probability. That is your limit of detection. And limit of quantification means that particular measurement value which will be with the stated precision and trueness.
Okay.
And if you see on the graph, you have a limit of blank, then you have limit of detection, and then you have the limit of quantification. Right?
एक और वर्ड है, बहुत बार रिपीटेडली यूज होता है और कहीं सारे हिमेटोलॉजी एनालाइजर्स के जो हैंडआउट है उसमें भी ये डिटेल्स दिया जाता है. दैट पर्टिकुलर वर्ड इज अ कैरी ओवर. सर, कैन यू एक्सप्लेन व्हाट इज दिस कैरी ओवर एंड हाउ इट इज डिराइव्ड?
So, see, in hematology, if you have a sample of a leukemia, it may have count more than, say, 2.5 lakhs or 3 lakhs of WBC per cubic millimeter.
करेक्ट, करेक्ट.
And you can have a next sample, you don't know, that can be a leukopenia,
राइट,
who may
राइट.
have a count about, say, 500 to 7,000 WBC per cubic millimeter.
करेक्ट.
Now, if your instrument is having a carryover, then from the earlier sample, all those WBC will be carried over and will be reported in the
Right.
next leukopenic sample. This may happen also with, let's say, if you have a polycythemia case,
करेक्ट.
where your hemoglobin may be about, say, 21 or 22 gram per DL, and you have an anemic patient who has
Yes.
a value of about, say, 2 gram per.
राइट.
So there can be carryover.
So for
Similarly, this can happen for your thrombocytosis and a thrombocytopenia.
cytopenia,
Right?
right.
You may have a platelet count of about, say, 14 lakhs or 15 lakhs. And your next sample, which can have a count of about, say, 5,000 platelets per cubic millimeter.
Correct.
So, the manufacturer has to let the end user know the carryover results by performing some carryover.
Right.
And in that carryover experiments, they have to select high target value samples, low target value sample, and there are specifications which are given in this CLSI document which I referred, H26. What should be the high target value for samples for WBC, platelet, hemoglobin? Similarly, for low target value, they have specified ranges.
Right.
And the manufacturer has to have such samples for these experiments. Clear, sir? Now, say we are taking example of a WBC count, which is a very high count, high target value, more than 90,000. And other is a low target value sample. So what you will do, you will run the high target value sample for 3 times. So you will get 3 results from the high target value.
Correct.
Similarly, you will run the low target value sample 3 times. You will have 3 values.
Correct. Correct.
And the formula for carryover is you have LTV1 minus LTV3 divided by HTV3 minus LTV3 into 100. That is the carryover.
Okay.
And most manufacturers will give you that carryover validation results. But if the manufacturer is not specifying, then in general, the carryover should be always less than 1%. But
Correct.
all those good manufacturers, they do this carryover studies and let know the end user what is the carryover, and it should be less than this particular value, and they are mentioning this in their performance specifications in the operator manual.
Yes, that is normally all the, even the handout or even the operation manual, this particular term is already given and they are giving it specifically for each of the parameters which are being measured by that hematology analyzer. So that's wonderful. One another term which also is seen many times by as a claim by the manufacturers of hematology analyzer, और वो term है आपका imprecision.
Right.
तो इसको सर आप कैसे देखते हैं imprecision?
So imprecision, when you say, that is, we are basing this on running a stable material.
Okay.
For a number of days. Now, if you are that particular lot of control, which is a quite a, so what the manufacturer will do, he will have a specific lot of control and he will run that particular control for, say, 20 days or 30 days.
Correct. Correct.
In the same environment, same person, maybe there is no recalibration, and that will give you a short-term imprecision. Means your technician may change, you may have change in the reagents,
Right.
maybe you have some maintenance in it,
Right.
environmental conditions may change.
Correct.
So there are many factors which are going to affect.
Right.
Another point what I am to stress is, most of the analyzers, they have different modes. One is your regular or normal mode,
Right.
and other is a pre-dilution.
Pre-dilution.
So
Yeah.
your
Correct.
imprecision has to be evaluated in both your
Okay.
regular or normal mode
Right.
as well as the pre-dilution mode. And the manufacturer has to give imprecisions for both modes, short term and long.
Correct.
I hope
Correct.
I am clear on this.
Absolutely wonderful. This was something, which has been very frequently talked about. And I think it's made very clear. Yes, obviously, there are a lot of hue and cries for the different modes. Now you have a whole blood mode, you have a pre-diluted mode, new instruments, some of the new instruments which has come, they are using the capillary whole blood mode. So as you are very rightly saying, the short-term and long-term imprecision in both the mode as well is
Should
to be given by the
Manufacturer.
manufacturer for the
End user.
end user. Correct. One another term, and that we would like to know, and that is about the correlation. What is that correlation? What is the meaning of that correlation?
So, when you are having a new instrument in your laboratory, or the manufacturer is coming in the market with a new instrument,
Right.
so that is your test automated analyzer, TAA, and then you are comparing your performance with a analyzer which is already established in the market. That will become your comparable automated analyzer, CAA.
Correct.
Now you have to have some, when you are designing this validation tree, you have to specify what number of samples you will run, and these samples, they have to be distributed amongst your analytical measuring interval. 30% should be below the known, 33% should be within the known, and some 33% should be above.
Okay.
And these all samples, whatever number you choose, maybe 60 or 100, they be distributed amongst these three. And all those samples are to be also assayed on the another analyzer, test analyzer, as well as the comparative automated analyzer. And then the results are to be compared. And these experiments are to be done within 8 hours of sample collection.
Okay.
And sample preferably is to be collected in EDTA. K2
Right.
is the preferred sort or the antibody.
Why EDTA K2 only? Because there are K3 also available.
But CLSI recommends that you should have K2 because it maintains the volume of the cells. Salt doesn't change your
Right.
cell dimensions, things like that. So, as per CLSI H26, K2 EDTA is preferred
And that would be applicable on 3-part and 5-part because there are
analyzer. And when you are doing this comparability study, you have to do linearity assays. Then there are some other statistical analysis like your blend Altman plot. So there are some comparability studies.
okay.
And the results should be comparable. And this is what is termed as comparability studies.
Okay. So that's a very important information which I think we are already talking about for the validation part for a hematology analyzer. Mostly the data, as you are suggesting, should be generated by the manufacturer before giving the instrument to the laboratory owner. Okay. For an hematology analyzer, what are the minimum performance specification which are to be used by the end user?
So now, as you are asking, the instrument has come to my laboratory.
Right.
I have my operator manual.
Right.
Manufacturer's claims are stated in the performance specification. And as an end user, I have to verify the manufacturer's claims.
Okay.
The minimum what the end user has to do is to check for accuracy,
Right.
precision, your analytic measuring interval, and your reportable range for your biological reference interval. These four parameters have to be evaluated by the end user before placing the instrument into use. And then the end user has to verify the manufacturer's claims termed as verification.
Does this all tests and everything done by the end user is supposed to be recorded according to any of the accreditation body's requirement?
Definitely, because you have to have your own CV,
Right.
your own bias,
Right.
and then based on this CV and bias, if the laboratory will calculate its own total analytical error,
Correct.
and this total analytical error is then to be compared by the total allowable error given by various IQA program and other agencies. And these details, they are available on Westcard website in the consolidated performance specifications for hematology. So my viewers, they are requested to visit Westcard website and check for these performance specifications.
Okay. So before, as a patient, I am declared as an anemic or I am declared as a dengue infected person by using the CBC analyzer by a laboratory. There's a lot which is supposed to be done by both the manufacturer who is supplying the instruments or the end user who is using that instrument to provide the patient information to provide the correct diagnosis. Thank you very much, Dr. Karsab, for providing this very, very useful information and hints as well as tips for the quality control of hematology analyzer. We are very sure this information will be immensely important to all the laboratory owners who are using the automation for hematology to achieve a common humanitarian goal of providing the correct results for useful and timely diagnosis for the patient and thereby helping the society. Thank you very much.